Hello everyone. In this video we will discuss divergence and curl of electric field. So let us start with the first, that is divergence of electric field. So here, according to Gauss law, that is integral form of Gauss law is E dot dA vector. This is equals to 1 over epsilon naught Q enclosed, that is total charge enclosed within the closed surface. So according to Gauss law, the electric flux through any closed surface is equals to 1 over epsilon naught times the total charge enclosed within that surface. Now to convert this integral form into differential form, so we will apply divergence theorem. When we apply divergence theorem, then we can transfer the surface integral into volume integral through this relation, that is divergence of electric field, and here we have a dV and V is the volume integral. And similarly, here we have a total charge enclosed. This total charge enclosed, this is equals to rho dV, and again here we have a volume integral. Basically here rho is the volume charge density. So when we substitute the value of E dot dA and total charge enclosed in the equation first, then we get del dot E dV is equals to rho dV. Okay, so on both the sides we have a volume integral. Now here we will eliminate the volume integral. So when we eliminate volume integral, then we get del dot E is equals to, definitely here will be, we have 1 over epsilon naught, so rho over epsilon naught. So here the divergence of electric field is equals to rho over epsilon naught. Actually this is known as, or this relation is known as Gauss law in differential form. Okay, so this is the Gauss law in differential form, that the divergence of electric field is equals to rho over epsilon naught. Okay, so next we will discuss curl of electric field. So for this, suppose we have a single point charge Q, then the electric field for this is equals to 1 over 4 pi epsilon naught into Q over R square into R cap. So here we will calculate we will calculate line integral of electric field from point A to point B. That is, we want to find the electric field from point A to point B. Now here, suppose here we have a point charge Q, and suppose this is a x-axis, this is a y-axis, and this is z-axis. And suppose here we have a point A at a distance RA from the origin, and suppose here we have a point B at a distance RB from a origin, and we want to follow this path, that is for the line integral. Okay, so here in spherical coordinates, dl is equals to dr r cap plus r d theta theta cap plus r sin theta d phi phi cap. Or in our case we can write E dot dl from A to B, and E dot dl is equals to 1 over 4 pi epsilon naught Q over R square. In place of dl we can write dr, vary from A to P. Or we can write Q over 4 pi epsilon naught. Here we have R minus 2 dr, and we will shift from A, that is RA, to RB, because the distance from A to origin is RA and B to origin is RB. So limit vary from RA to RB. So we can write here Q over 4 pi epsilon naught R power minus 1 to minus 1 from RA to RB, and this is equals to minus 1 over, there is Q over 4 pi epsilon naught and 1 over RB2 minus 1 over RA, or Q over 4 pi epsilon naught, here we have 1 over RA2 minus RB. So here the line integral, that is electric field, is equals to Q over 4 pi epsilon naught into 1 over RA minus 1 over RB. Now here the integral around a closed path, this is evidently 0. When it is 0 for RA equals to RB, that is the line integral around a closed path is 0 when RA equals to RB, that is E dot dl, this is equals to 0. Now here we are interested to convert line integral into a surface integral. To convert line integral to surface integral, we will use Stokes theorem, that is by applying Stokes theorem we can convert line integral into surface integral through the curl of electric field, that is this. Okay, or we can write del cross E dA is equals to 0. Okay, so now here we will eliminate the surface integral. So when we eliminate the surface integral, we can write del cross E is equals to 0. So this is the case when we have a single charge. Now for bunch of charges, that is when we have a number of charges, in that case total electric field is the sum of the electric field for charge Q1, electric field for the charge Q2, and electric field for the charge Q3, and so on. And again when we take the curl of this, then we can write like this: E1 plus E2 plus E3 plus so on, or we can write del cross E1 plus del cross E2 plus del cross E3 plus so on, and this is again equals to 0. That is curl of electric field is equals to 0. So here in this lecture we discuss the two relations. One is divergence of electric field, and second is the curl of electric field. So divergence of electric field, that is del dot E is equals to rho over epsilon naught, and del cross E, that is curl of electric field, is equals to 0. Thank you.